Hello and welcome to SDNTechForum. Today I'm going to discuss a very interesting and important topic for network engineers who are working in cloud. We are going to deal with AWS Cloud WAN. So let's understand what is AWS Cloud WAN. So the question is, what is AWS Cloud WAN? AWS Cloud WAN is fully managed global network service that simplifies cloud network architecture and helps you connect your cloud VPCs, on-prem resources, and AWS services over global network with low latency and high throughput and seamlessly integrate AWS resources. And that's what we have here on the screen. You can see these are the few capabilities of AWS Cloud WAN managed WAN service. It is a centralized platform fully managed by AWS. Then it provides you a centralized dashboard so that you can visualize your global network irrespective of region and other things. And then it is very policy friendly. That means automation friendly. You can write policies and make those changes. It helps you create network segmentation. So you can create VRF like segments, and then you can share this core with multiple AWS account like your partner, vendors, even with other organization. And then it support attachment. It support different type of attachments like site to site VPN, VPC attachment. You can connect your on-prem SD-WAN, and you can also connect your transit gateways. So these are some unique capabilities of AWS Cloud WAN. That's why it is so popular. And obviously, AWS offers their core network, so you get low latency and high throughput. With that, let's go and understand how we arrived here. That means what were the solution before AWS Cloud WAN. And here you can see you may have VPCs in the cloud and they are region specific. So when you want to connect two VPCs, initially we'll have a VPC pairing. That means you pair VPC1 with VPC2 like this, and then you have a VPC3. Then you want to connect them, you have to create another pairing. And in this case, you can see VPC2 can talk to VPC3. However, VPC1 cannot talk to VPC3 because VPC pairings are not transitive. So what you have to do, you have to create another pairing from 1 to 3. And this is manageable. This is okay if you are handling a small network, but you can understand we are quickly running into scalability challenges. So to solve that, we had another concept which is called transit gateway. And here you can see we have two VPCs in a region. And if you want to connect them together, you can use a concept like called transit gateway. So transit gateway can connect to one or more VPCs in the region. So no matter how many VPCs you have in that region, you can all connect them to one single transit gateway, and the transitive VPC pairing problem was solved. But what was the problem with this design? With this design, the problem was the region. Here you can see we have two transit gateway in two different regions, region 1 and region 2. And now if you are in a situation where your VPCs are spread across the region, then you need a transit gateway pairing between the regions. So this is good, but not uh, very optimal. Now let's understand, if you have a distributed network, that means your VPCs are distributed across the globe, and you don't want to go through the hassle of like building your own network and all those things. That's where the Cloud WAN comes to rescue. And what you can do, it's a very much automated and policy based thing. It's fully managed service. That means AWS is responsible for managing this behind the scene. So what you can do, you can create a global network, and then you spin up your core network edges like POP locations and connect your VPCs to those core network edges. Next time you have another VPC coming up in a different region, it's quite simple. Just add another CNE edge location to your global network, and then you connect that VPC via VPC attachment or any other type you wish to. Within this, what I'm not showing is a segmentation part. So you can also have segmentations like a VRFs, VRF production, VRF development, and I'm going to show you when we actually go to the demo. So this is Cloud WAN architecture. Before we go to the lab, Let's refresh our knowledge about AWS networking concept. Here you can see we have region and availability zone and VPC and subnet. This is all about VPC. We have talked about this in detail, in length in our AWS crash course where we have 20 plus videos. So if you haven't watched that, please go ahead and subscribe to that, watch that in your time. Internet gateway, we know that anything spin up in the public subnet, they get the internet connectivity by internet gateway, which is again a managed service. And then you have a load balancers to load balance your work stream. NAT gateway is like a one-way NAT. If you have something in private subnet and you need to go out or reach internet for some updates and other things, then you come up with the NAT gateway. VPC peering, as I just mentioned, if you have VPCs and you want them those subnet to talk to each other, you can go with VPC peering. But if you have multiple VPCs in different region, then probably this is not the best scalable thing. Transit gateway, this comes to rescue for VPC peering scalability issue, but this is regional concept. Transit gateway is a regional construct. Hence, if you have VPCs in more than one region, you'll need multiple transit gateway. Not bad that much. VPC endpoint. This allow private connectivity, like if you have a S3 or RDS, DynamoDB instances, AWS resources basically, and you want to connect them and you don't want to go over the internet, you can use something called VPC endpoint. Private link. Private link is very interesting. It allow you to talk to other VPC or other organization privately by exposing without exposing them to internet. So you get like a private connectivity to other VPC. It's mostly come into a situation where you have a partner or vendor and they want to consume some services from your VPC, but you don't want to expose entire VPC. Then private link is one option. Site to site VPN, classic network design. So you have one site on-prem, you have another cloud VPC, you want them to talk to each other. Site to site VPN is a way to go. Eh, However, the drawback is it uses internet. The best part is it's all secured, encrypted. Client to site VPN is like we all use from if when we are working from home and you want to access some of your org resources. What do? You fire up your client VPN, you start your any Cisco AnyConnect or any kind of uh, client, VPN client, and connect to your network. Route 53 is about DNS services. AWS provide you the internal and external DNS services, and CloudFront is CDN, which help you distribute your static content and reduce latency by connecting to AWS region via dedicated network. VPS flow log. Everything what you do, I recommend send a log to VPS flow log, store it somewhere so that you can do forensic and analysis. With that, our AWS discussion is never complete without talking about pricing. So anything we do, we first take a look into pricing so that we know what it costs. And I highly recommend you, if you are following me to build AWS Cloud WAN, go ahead, kill those attachment, clear the CNEs, delete your global network. Otherwise, you may incur unnecessary charges if you are not using the services. Pricing, AWS Cloud WAN pricing. This is a big document. We are not going to read it to get to all of it, but you can see there are multiple component for this solution. Cloud WAN, like core network edge, data processing, attachment, and peering, and each of them incur cost. So let's take example. Cloud WAN pricing, core network edge CNE is 50 cent per hour, and data processing is 2 cent per gigabyte, and core network edge is varies by region. So depend on where you are, you have attachment prices varying. So let's take an example here, and this says traffic within region. So CNE monthly cost is 365. You obviously will use attachment and minimum have two VPCs so that VPC1 can talk to VPC2 over global network. Hence, you'll have roughly 94.9 T dollar per month, and data processing, it has taken an average of data 100 GB and all those things. Finally, this calculation says you are almost paying roughly 460 or close to 500 bucks per month if you are within region. When you have traffic between region, you know the traffic between region incur cost. So here, let's see what is happening. We have CNE monthly cost, and this is big, 730, almost doubled. Then we have CNE attachment and data processing charge. Finally, you can see 840 per month, roughly. That's what you will pay for minimum two VPCs talking to each other within different region, 800 within region, 450. So please be mindful what are the component bearing charges. I advise if you're not using Cloud WAN, you're using it only for learning purposes, go ahead and clean up everything. With that, let's take a deep dive into lab and grab a cup of coffee. It is going to be exciting. Let's go ahead and build AWS Cloud WAN for our use case. Here, as you can see, we have three VPCs, two VPCs in US region, VPC prod and VPC development. And then we have another VPC in Europe region, which is VPC prod. What we are going to do, we are going to create first a global network that is in dotted line blue, and it has a default segment, and we'll call production our default segment. Then within global network, we are going to add another segment that is this red dotted circle. It's a representation for development segment. So you can think of these like a VRFs. By default, all the CNEs they can they all have the same VRF. As you spin one or more CNE in different region, they'll have all the VRFs by default. But you can restrict that with configuration or policy, and I'll show you that. So that's about our global network, core network, and segmentation. Then towards the VPC side, we're going to create attachment policy and see how these CNEs are getting attached to VPC. And that is one-to-one VPC to segment mapping. So each VPC gets associated with one segment. So this is the planning part. We have three VPCs in two region, as I mentioned earlier, and then we are going to build a global network, and then we'll build two CNEs, one in USA, one in Europe. Third one I'm showing just for representation purposes. Say tomorrow you want to build something in APJC, then you can add another CNE, core network edge device. Here I'm trying to summarize the different steps we are going to follow to create Cloud WAN. The first step is kind of prerequisite. That means you must have your VPC and subnet created. Then we are going to go ahead and create a global network and core network. That is, you are creating a network of CNE, core network edge devices, with one default VRF in it. Then we are going to edit the policy because we would like to add more segment. So we are going to create another segment, development, and we would also like to do route leaking between those VRFs like production. You may have a situation like you have a shared services or centralized services which need to be consumed by all the users. Then you can obviously do this kind of route leaking. For our show and tell purposes, we are going to leak development routes to production routes, so the production user will have access to development subnet as well. And that we are going to do with this segment policies. Then we'll create attachment policy and define on based on what criteria different VPCs get associated with core network edge, and that we are doing by rule and using tag. So we will create a rule where we are defining a condition that if the environment tag is equal to dev, then go ahead and associate with the CNE. And finally, once you create your attachment, you need to go back to VPC and add a route towards the core. That's what we are going to do. So this is like a just for your reference. Let's go and start building the Cloud WAN. Right. Here we are in AWS console. Let's do a quick baseline. That means the VPCs we are going to use. Let's look at them. So I'm in Europe region, as you can see, and I'm going to say VPC. We have two VPCs, the default VPC, and I have created another VPC called Europe VPC. Pay attention to the CIDR. The default one is 172.31.16 and the non-default is 1048.64.18. So from Europe side, we are planning to use only one VPC and we will tag it as production VPC. Now let's go to Ohio East. And here again, we have two VPCs, a default and a non-default called MCS US VPC. CIDR is 1048.0048. Within these two VPCs, we have an EC2 instances running with public IP address assigned to that. We will use those EC2 instances to test or validate connectivity. So you may be now you should be clear with the planning part. We have four VPCs, but we are going to use only three, two in US, one in Europe. We'll have a production VPC at both sides, but in US we have one development VPC. The reason being each VPC they'll be mapped to a segment when we start building our cloud WAN, and we will do some route leaking between those two subnets or segments. So far, we have not talked about Cloud WAN at all. This is regular AWS stuff. So now let's go to AWS Network Manager and start building our Cloud WAN. You can go to services and you can search with Network Manager. Here you can see we have Network Manager. This is the landing page. All the AWS networking functionalities are here. We are interested in global network. Let's click on global network. You can see we already have a global network, and I'll tell you why. Let's go ahead and create one. The global network creation is quite simple. Give it a name, and description is optional. Then you can go inside and say include core network, add core network in your global network. Yes, we want to include a core network, and then you need to specify a name again. And we are not going to create, hence I'm just putting some placeholder here. The core network policy, it is asking for a BGP ASN range because it will create BGP peering between CNEs. That's why you need to use or provide a BGP AS range. Here we are going to stick to the same range, that is 64.5012 to 65.534. Edge location, that's the important part, where all you want to have your CNEs or pop locations. That means wherever you have the VPC resources, ideally you would like to create a CNE in those regions and then have this global network connect this uh, different CNEs distributed across region automatically for you. That's the whole purpose of doing uh, core network manager. I'm going to create one in Ohio and one in Frankfurt because those are the two places we have our VPC resources. And then segment name. This is your default segment enabled in all selected edge location. So whenever you create your edge location, you get a default segment. Think about it when you are creating routing between two router, you already have a global routing table or a default VRF. That's what it is talking about. So you will have a one default segment, but it doesn't stop you to add more segment. We'll add more segment by policy. So to start with, you have to start with one default VRF and next, and you can create segment. We are not going to do that. The reason being, we already have a global network created, and I'm going to click on this global network and show you what goes on under this. We have two edge location as discussed, one in Ohio, one in Frankfurt. And let's look at some details here. We have one segment, one default segment, right? So that's about it. The reason I have it created because global network creation is really fast, but when you spin up your CNE, the provision of CNE can take some time, 10 to 15 minutes. Hence, to save some time, I have already built our global network. That's all I have done so far. But Next, we are going to add more segment and do the route leaking, etc. using policy versions. So let's go. Once you create your global network, and this is my global network, you'll have a dashboard. You can go to core network. This is my core network snapshot, how it looks like you can go to topology graph, topology tree, and visualize things. Right now it's quite a simple visualization. We have a core network that has two CNEs. However, when you go to your global network, you will find additional options, and the one of the most important option where you are going to spend time mostly is policy versions. So when you create your core network, policy version 1 is created. It is execution succeeded. So let's see what is inside policy version 1. It's a policy detail. Here you can see we have our ASN range. We have not decided any cider block, but where we have our CNEs, these are the CNE location and segment a little bit from the planning. We are calling production, but here when I created I use campus. So now assume production equal to campus. That's what we are going to use. Okay, either you can edit policy, create policy in GUI, or what you can do, you can edit the JSON document and execute. You can actually download, edit, upload, and all those things you can do with JSON. But we are going to stick to GUI for simplicity. So now what we are going to do, we are going to edit this policy. So let's go ahead and edit. Once you hit edit and create a new policy, the version will be changed. Version will be incremented to 2. Here you can see choose policy view mode, visual editor or JSON. You would like to work with visual editor. So that is it. Edge locations are fine. What we want to do, we want to add segment. Right now we have one segment, which is campus. Let's go ahead and add another segment. Give segment a name, dev, segment description. This is optional. Require acceptance, attachment association to this segment require acceptance. We'll leave it empty. Isolation attachment, isolate access to an attachment from another attachment in this subnet, in this segment. And these things we can leave it default. Segment filter, right now you can see we have allow all. That means a segment, if it is a development segment in one CNE, it is by default it can talk to other development segment. That's what allow all is saying. And also interestingly, limit the specific edge location, so you can decide that development segment will be available only on particular CNEs. So let's go ahead and create a segment with the default options. So we have now two segments, campus and default. Network function groups, that's not needed. And segment action, let's go ahead and create a segment action. I'm going to say from campus, allow selected, and dev. So I'm saying that any subnet in campus VRF, they'll have access to dev segment. That's kind of like a route leaking. Say create sharing. So we have our segment action. Okay. Now the final piece is attachment policies. Here you can see these are like sequence rule, and we are going to create our first rule with condition. I'm going to say this is rule number 1, and you can put a description. We'll leave it default. Action attached to the segment option will say based on segment name, and attached to the segment, which segment you want to attach. I want first handle campus, so let's say campus, and then we'll create a condition logic and or we are going to select and. So we are saying that attached to segment, and if my condition is tag value equals, and tag key is environment, and I'm going to say campus, and you will see where we are going to use this value. Okay, so that's the my first one. I'll say create attachment policy. That's the rule number one. Let's create a duplicate rule or similar rule. Rule number two, where we are going to say attached to development segment, tag value environment is dev. So we have two rules created. So you can see within policy, we have created some network configuration. We have segments defined, added a new segment. We didn't do anything with network function group, but in segment action, we have defined some action here. And finally, attach policy. Let's go ahead and say create policy. You can see policy version 2 has been created and it's pending generation. So policy is working in the background, but it's not being enforced yet unless you say apply change set. So right now it's all planning part. There is no traffic disruption. Now it is ready to execute. So you can select this and say view or apply change set. That's what we are going to do. And then you can see what is happening here. All this change set. So what will be the new value we are going to add? We are going to modify. It is basically asking you for the confirmation. I'm going to say apply change set. And that will trigger it to execution. Now it is executing. We can look at the task or execution progress. Yep. This is a better view because it gave us a percentage. That's a good jump. Now 71% complete. 5 of 7 tasks been completed. Execution succeeded. All right, looks like our policy is in effect. Let's go ahead and see the policy version. You can see policy version 2 is live and latest. Now the next thing is attachment. So we have to create attachments for per VPC or per segment. Let's say create attachment, prod, edge locations. In US East, we have campus and attachment type is a VPC. VPC ID, pick up the VPC ID, and campus is our MCS US VPC. That's our campus. That's why I'm going to select that. And these are our availability zone populated. Now here you can see this is the key value we were talking about. So we are going to say environment and value is campus. Just the condition, how the condition we created earlier. And we're going to say create attachment. All right, to save some time, I have paused the video and now you can see we have 3 attachment created for 3 edge location and 3 different VPCs, 2 in US and 1 in Central. We have 2 attachment already available. Third one is still in progress and this can take some time. For me, it's going on for say 10 minutes already. We can wait for this one to be available and then we'll go ahead and create VPC routes. Good news, we have all the attachment available. So now the last thing what we have to do, we have to go to the VPC and add the routes towards the core network. So let's go to our US VPC first. Here I am. We'll pick up the non-default VPC. And within this VPC, we are interested into route table. Let's look at the route table and we want to see the public route table. You can see we have 2 routes. The first one is a default route going to internet gateway, and then the second one is a local route. So let's go ahead and add a route towards the VPC production in Europe first. Go /18. That's our other side of subnet. And from next hop or target, we are going to pick core network. And when you pick up the core network, you will see the ARN will be populated automatically because we have the global network or CNE created for this region. To say save changes. Now let's go ahead and try to ping other side of EC2 instance, which is in this subnet. And let me quickly show you that instance. All right, here we are logged into EC2 instance in US, and let's try to ping the other side, for which we just put the route, static route, and you can see this is timing out. The reason being we have not added route at the other side of the VPC. So let's go and do that. Add a route, a new route, because we don't want to delete any existing one. And for that, you can see 1048.0018. This should go to core network, and we have a core network route available here. I'm going to say save changes. This is it. So we have the route populated at both sides of the VPC via core network. Let's go and do our check again. All right, we have the routes added at VPC, and I have made one small change, and that small change is the I have changed the EC2 instances from Amazon Linux to Ubuntu, because it's kind of like easy to troubleshoot something network related in Ubuntu. And you can see this is Ohio EC2 instance with a private IP address of 10.48.3.21. Let me show you the next same thing in Frankfurt. And for Frankfurt, we have one EC2 instance running EU test. Let's go into that. And that's the private IP address of 10.48.67.39. So one is in 10.48.0018, another one is in 10.48.64.0.18. Two instances in US and Europe. And for VPC, we have added the route. Before we go there, let me quickly show you one more thing. That's about the security, because we rely on ping or ICMP checks to make sure that Cloud WAN is working end to end. So I have added one small thing, that is allow protocol ICMP from any subnet. And this is just for the testing purposes. I'm going to clean up these rules. Okay, so now let's go to VPC. Now let me show you the VPC route table one more time. And here we can see for the public route table, we have default route to internet gateway. Then we have the local route, that's 64.0 here because we are in Europe. And then we have other side of the network, that is 1048 via core network, and vice versa. When you go to Ohio, it's opposite to this. All right, with that, let's go and log into those two EC2 instances and run the ICMP check. Here I am logged into those EC2 instances. The first one, as you can see, has an IP address in 64 subnet, 67 subnet, that is in Frankfurt. And then we have one in 48.3, that is in US. So let's try to ping both sides. So first I'm going to copy this and ping it from US. We are pinging from US instance to Frankfurt instance, and you can see we can ping it. And we are going to do the opposite, which is really not needed. Let me do that. All right. And you can see the ping is going on at both sides. So we are good. We are using Cloud WAN to connect two different VPC without any VPC peering, transit gateway. And this is really scalable. You can do route filtering, route sharing, segment sharing, and all those things. So I hope you like this video, and I'll see you in the next video. Please do like, subscribe, and share. Thank you.